Hi everyone, we're Team Pangaea, and although we're based in the UK, we believe that we can work together with the community of Playa Blanca in Peru in order to design and create an eco air conditioner which runs on minimum renewable energy. It will allow the workers in the community centre to work in a safe and comfortable environment without being affected by dust or high temperatures. Bear in mind that the people in Playa Blanca do not have access to many resources, so we had to come up with a design that used simple materials that were easily available to them. On top of that, the design had to be cost effective both in the long term and the short term. Safety was also a key factor that we had to consider, and of course, the idea had to work. So, taking all these factors into account, we have decided to build an eco air conditioner made with plastic bottles. There are four units: cooler, filter, fan, and a ventilation unit. So, first, the cooler. The wall into which the wind blows will be covered with plastic bottles in a wave like design to increase the surface area and to make it look a bit nicer too. The plastic bottles will be placed in the wall with a wide part facing the outside of the building. Hot air will rush into each bottle, which is pushed towards the rim. The pressure therefore increases, which cools the air before it enters the room. You're probably thinking this is not going to work, but you can test this idea yourself. Blow in your hand with your mouth wide open. The air is hot. Now, when you blow with your lips pursed, the air is cool. Mind blowing, I know. Eco coolers do the same thing. They're able to lower the temperature by about 5 degrees. Now, the filter and fan. These two units will be placed just before the water bottles in a box outside the wall, in order to ensure that enough clean air is coming in. The first part of the design is a dust filter. It consists of several membranes which will block out different particles of dust. These membranes will have to be cleaned an average of twice a month to avoid any blockage in the system and let the air flow. In the long term, the idea is cost effective as the filters are reusable and can be washed simply by using water and an adequate detergent. Then the filter unit is followed by a small fan. We decided to add it as it consumes very little electricity, which can be supplied by the small wind turbine or solar panels in the community centre. This will make the whole design reliable as it can also be used on hot days with very little wind. The box in which these two units will go will not cover the fan so that air can flow in. Then the ventilation unit. For this, we have taken inspiration from nature by looking at the way termite mounds work. We saw that, according to buoyancy drive stack ventilation theory, hot air rises because its density is lower than the density of the cool air. Therefore, we have added a couple of chimneys to the design. This will allow the air to flow so that cooler can come in and replace the hot air, which will rise and escape through the chimney. We believe this idea is the best one for many reasons. Firstly, it is environmentally friendly, it does not contaminate the air or soil, and it also recycles the water bottles in the town. It is also cost effective as this process runs with very little electricity, which is supplied by already existing wind turbines or solar panels. Therefore, there are no running costs. The materials used are also very cheap. Water bottles can be recycled, the chimneys can be made with the same material they used to build the rest of the building. Dust membranes are reusable, so the only maintenance cost will be the detergent used to clean them. And finally, the box in which the fan unit and filter unit will go is also made out of a very cheap material which can be obtained from the village. Therefore, all the materials are fully funded by wind aid due to the low cost. And finally, the system is safe to use and effective.